Welcome back, I'm that Chemist. Today we have a story which involves the eruption of a bromine volcano. But first, a message from our sponsor. This video is sponsored by ExpressVPN. Have you ever wanted to stream your favorite show, but you can't find it because it's unavailable in your region? Well, with ExpressVPN, you can virtually change your location in the world by pressing 3 simple buttons. A VPN is like lab goggles. It protects your privacy and keeps your data safe from snooping eyes. Since ExpressVPN uses high-end servers, you don't have to worry about lag and buffering when browsing or watching your favorite YouTubers' content. Wink wink. ExpressVPN is like a periodic table. It provides a comprehensive list of available servers and protocols, giving you the flexibility to choose the best one for your needs. So if you're afraid that you're going to be on a list by looking at your favorite YouTubers' chemistry content, wink wink, sign up for ExpressVPN using my link and get 3 months free and protect yourself from being on the Glowies naughty list. I want to thank ExpressVPN for their support of this channel. So here's a small story about one of my first syntheses as a physics lab tech in a chemistry research lab. After training, I went to replace a technician in a group which had just been there for 1 year. My boss heard well of me, and so she let me decide how much help I need to get going in synthesis. We work with MOFs, which are metal organic frameworks, and I started out by synthesizing the organic linker. In this case, this starts with tetrabromopyrene, which is made from pyrene and bromine, which both for themselves are not too expensive, but the product is. Another PhD already tried the synthesis and didn't get any of the product they were trying to make in sufficient purity. Purification is hardly possible due to insolubility in anything. However, I will point out here that as a chemist, if something doesn't dissolve in anything, that means that you can get rid of everything else by dissolving it in something. So you can probably find a solvent that will work to purify stuff. Oftentimes, if you can't find something to dissolve it, you just haven't pushed it far enough. If you are a chemist and you're ever trying to dissolve anything, I'd recommend trying something like hexafluoroisopropanol. You can also try recrystallizing from glacial acetic acid, and that's another one that occasionally works. You go from hot glacial acetic acid, cool it down, and that can sometimes solve your problems as well. I heard of that and said, hey, it will hardly brominate more than the 4 designated positions, so let's hit it harder. I took the unfinished material, rebrominated it, and it worked well. So I took a full-size batch, over 10 grams, and hit it with 8 rather than 3 equivalents of bromine. This is a lot of bromine for a typical bromination. I've never seen a bromination that involved 8 equivalents before, but they are putting 4 bromines on here. So technically this is only 2 molar equivalents, relative to how many moles of bromine are being added. I not only spilled the red juice onto my gloves, but I also didn't think it through well enough. First of all, as soon as the bromine hits the solution of pyrene, the product starts crashing out, clogging all stirring. So I manually swirled it while adding more solvent, avoiding to get in contact with the extensive amounts of bromine vapor. Luckily, my hood worked as well. When I got that sorted, I closed everything and started heating. Oh boy, the vapors just came out of every joint, so I greased them with even more sulfuric acid, directing the vapors into a trap with thiosulfate solution. After the reaction, all of the metallic stuff in my fume hood tarnished a little bit, but we managed to get our product cheap and fairly easily. And after decreasing the equivalents to 6 and optimizing the solvent amount and order of steps, I could even manage to get it to be tame. Boy, I learned fast, and by now, am a very happy chem junkie. And until today, running the reaction is commonly referred to as starting the bromine volcano. Here's an image for reference. This looks like your typical bromination. Here they have this condenser, which is called a Dimroth condenser, not super common in research labs, but you come across them from time to time. And the bromine is not effectively condensed because you can see there's bromine going down the sidearm. Also, very nice use of a 2-neck round bottom flask. I've worked with bromine myself several times. The one thing you have to be really careful about with bromine is when you brominate stuff, it can be really exothermic, and that can make the bromine boil, and boiling bromine can be pretty dangerous. If you ever try to make chlorine using the TCCA hydrochloric acid method, this is basically chlorine plus and chlorine minus, do not quench the remaining waste with NaOH. Not only does the TCCA form chloroamines, including the spontaneously detonating nitrogen trichloride, with hypochlorite, sodium hydroxide can actually cause it to decompose. Basically, there's like these nitrogens in TCCA, trichloroisocyanuric acid, and when this reacts with NaOH, it releases ammonia, and what happens when we mix bleach with ammonia? We make nitrogen trichloride, also known as trichloramine. I didn't think anything would happen other than just the remaining dissolved chlorine being destroyed, but upon addition to NaOH, it started bubbling, and then the smell hit me, a weird ozone chlorine-like smell. Only then did I realize that something weird was happening, and I moved away from it immediately. Luckily, the wind was in my favor and I didn't inhale any of the gas, but it definitely could have ended badly if I was unlucky and got a lungful of the gas, or if it had just spontaneously detonated. Yeah, you definitely got super lucky here. This is one that I probably would have missed, considering the hydrolysis of TCCA to form ammonia is definitely something concerning. It's something I haven't thought of before. If you've ever had something similar like this happen, make sure you let me know down in the comments. If you're not sure what TCCA is, by the way, this is just pool bleach, and it's really cheap because people use it for pools, so sometimes people use it for chemistry as well. Speaking of the story about someone snorting bromine, a long time ago in chemistry class, the chemistry teacher wanted to demonstrate the ability of halogens oxidizing each other by setting up aqueous solutions of iodide and bromide ions, then using aqueous chlorine to oxidize the bromide back to bromine, then using that to oxidize the iodide ions back to iodine. The samples were then sealed and passed around so that everyone could get a good look. However, when the samples reached the back row, an individual decided to open the chlorine vial and snorted the vapors. He immediately began coughing and wheezing. Then he raised his hand and asked the teacher if it was dangerous to inhale chlorine. Ugh, this is just so stupid. His friend, who is a bit of a class clown, said that the coughing was BS, then proceeds to open the vial now containing aqueous bromine and inhaling those vapors, followed by a similar coughing fit. These guys are so stupid. Do not do this, guys. This is so dumb. This was a point in our education where everyone knew how dangerous chlorine gas is. I would hope so. I don't think I know anyone who would go out of their way to breathe in chlorine gas, even if they've never been into a chemistry lab in their whole life. I had a job in the fresh fruit industry when I was 15 years old, and the amount of chemical negligence in that facility was crazy. The first time I was chlorine gassed, so to speak, was when our chemical regulation worker kept dumping more and more chlorine in the frothing baths each time instead of using litmus paper and checking the ppm properly. Eventually, after constant addition to the water, there were these large yellow-looking bubbles forming in the bath, and soon enough the whole staff team was tearing up and coughing, until our boss came out of their office and shut us down to go outside. Next year, when I was 16, it happened again. Same thing, chemical regulation worker kept adding more and more, same result. But the last time I worked at the facility was when I was cleaning the machines on a night shift with a friend. The cleaning solution we used was very strong and had gotten into a previous night shift worker's PPE and soaked the suspenders of his pants and chemically burned an X into his back. Oh man, that's awful. I'm guessing here that these frothing baths are just like a way to sterilize the fruit. I didn't realize that fruits were bleached. I don't know too much about the commercial preparation of fruit for consumers, but I am interested in doing a video about anti-ripening gases at some point. If you know anything about this, you're welcome to reach out, and I'd love to hear what you have to say. But my last chlorine interaction was my boss adding unknown amounts of chlorine to my cleaning solution. I was working in the back room of the facility by myself and began to feel extremely nauseous and sick, so I went outside and felt better. But the second I came back inside, the whole building reeked of chlorine. I continued and went back to work, and about 10 minutes later, the same effect. Had to go outside and get fresh air. I didn't find out until the morning after our shift that the boss had added chlorine into our solutions. I had no chemical respirator or face mask of any kind, just lab goggles and a water-resistant jacket and pants. This is a sketchy place to work for sure. Yeah, it sounds like it. This sounds super sketchy. I think it's good for people to understand how things are made so that we know when sketchy stuff is happening like this. This is awful. I'm currently a PhD student in physics, but back in high school, I had the bright idea of wanting to make fluorine gas. Now, if you're as lacking in the common sense department as myself, I implore you, please do not ever try this at home. Honestly, I doubt any of you could even make fluorine at home because it's just such a complicated thing to make. Like, maybe you could technically make it, but you couldn't, like, make it on a preparatory scale. If you could do this, Tom would do this, and Tom has not done this. Fluorine and HF are some of the worst chemicals you can ever possibly work with. True, and for HF especially, skin exposure of even 1 to 2% HF can be fatal. This I'm not 100% sure about, because you can get tile cleaner and stuff as an individual, which has HF in it. So if it was lethal from 1 to 2%, I would be a little bit concerned. And I think toothpaste would have a bit more of a hazard to it. Nonetheless, it's probably the dose that matters here, not just the concentration. I was an egotistical word that I didn't blur ahead of time as a teenager, and it's a miracle that I'm alive today. With that said, here's my misadventure for your enjoyment. The inspiration for this project was the original Nile Red video of bromine synthesis from pool supplies. Upon seeing that video, I thought, fluorine is a much more reactive and thus more interesting halogen than bromine, so I should make that. Now, I had just finished AP Chem, and I thought I was hot stuff for knowing what a Hamiltonian was, so I dove into the project with reckless abandon. I bought some sodium fluoride online to mix with azeotropic sulfuric acid from my existing chemical inventory. I had a decent OChem lab going, and proceeded to distill the stuff in a field behind my house. This setup consisted of a Teflon beaker as the heating flask, PTFE piping, this is just Teflon, as the condenser, and a random HDPE plastic bottle, this is just high-density polyethylene, it's a type of polyethylene, as the receiving flask. held together with copious amounts of plumber's tape, three-way clamps, and blind hope. Yeah, I bet there's a lot of blind hope here. Shockingly, the process went smoothly, and while I don't have a precise number for the final concentration because 1, it didn't matter too much for the following step, and 2, I really did not want to do a titration, a hydrometer measurement showed approximately 50%. And thus, I had some 100 milliliters of liquid death in a cola bottle. Now, following this paper from the 60s, I don't know what people were smoking in the 60s, but some of the wildest papers I've ever seen are from that period. I proceeded to set up an electrolysis cell. The electrolyte was HF and potassium fluoride. I don't know why, the paper called for it and I complied. When you mix potassium fluoride with HF, you get something called potassium bifluoride. This is KHF2. This is a little bit more stable and it's safer to work with. For electrodes, I use these hideously expensive platinum iridium ones. Now, the product of this reaction is a mixture of ozone, oxygen, and oxygen difluoride. Oh no, this is awful. On the anode, oxygen difluoride decomposes at mildly high temperatures into fluorine gas, which is the desired product. All of this was collected into a vacated CO2 canister, partially backfilled with helium so as to not suck up the water into the system. It was the most suitable container I could find at the time. This is such a bad idea. The electrodes were powered by a car battery with a voltage multiplier. Somewhat ironically, it wasn't the chemistry that did me in, but my shoddy electrical engineering. A bad soldering job had resulted in the Teflon tape I had been using as a seal around the electrodes to melt due to arcing, allowing gas to escape. I didn't know this at the time, and my first indication that something was wrong was when my eyes began to tear up and I began violently coughing. Oh no! I remember a description from I think Down the Pipeline blog where someone had described inhaling chlorine as having an elephant step on your chest, which was really the most accurate description of my feeling at the time. Now I was in the middle of a field, so I had to sprint home with tears streaking down my face to get the garden hose to rinse my eyes. I wash using a garden hose as an eye wash station. What are you thinking? After stripping down, I ran inside the house to rinse myself off in the bath. Fortunately, the only long-term consequence of this incident has been asthma-like symptoms which have persisted 6 years later. My eyes were fine, at least from what I could tell, being nearsighted enough already. Hopefully this really highlights to you that you should not be making HF at home, and you should also not try and make fluorine at home. This is a really dangerous thing to do, and even this person who failed at making fluorine succeeded at getting asthma-like symptoms which have persisted 6 years later. Do not try and repeat any of the stupid stories you see on this channel. Unfortunately, my home lab did not survive, as my parents were obviously not pleased with their child trying to speedrun life, and I had my chemicals confiscated. But my lack of access to chemicals was what got me into physical chemistry, and later physics, so eventually everything worked out in the end, I suppose. TLDR, Chemist tries to be an electrical engineer and gasses themselves. Yeah, I guess that is what happened. In my first year of teaching, I had a student in Gen Chem 1 who decided that, rather than going through the bother of using a striker to light his Bunsen burner, he would use a faster, more efficient method. He proceeded to grab a wad of paper towels from the dispenser, stick them into the lit burner of the student next to him, and light his burner with his improvised torch. To top it all off, he then threw the flaming paper towels onto the ground and stamped them out with his feet. The students around him screamed and scattered. He did this so quickly that I didn't have time to say anything, and after it was all done, I was literally shocked speechless. Apparently, he had taken chemistry previously in a foreign country. He told me that this was how they did it there. I was once brominating a maleimide with pure bromine that came in an ampule. I put the leftover bromine into a scintillation vial. This is just a vial with a cap, but because of the density of liquid bromine, 3 grams per milliliter, some of it spilled out of my pipette. This is basically like the surface tension in the bromine can't hold it into the pipette. I often worked with light-sensitive compounds, so I'd always wrap my vials and intermediates with aluminum foil to prevent light from entering, so they wouldn't degrade. Those few drops of spilled bromine happened to land on the aluminum foil, and suddenly there was smoke, and the aluminum lit on fire. At first I didn't know what was happening, but then I realized that bromine and aluminum were probably reacting with each other to make some inorganic compound. After doing some research, I realized I was probably making aluminum tribromide, and the reaction is very exothermic. The moral of the story, keep bromine away from aluminum foil. If you haven't seen the reaction of bromine with aluminum foil before, I'll include a link to that in the description of this video. It's not something to be messed around with, and it is very, very dangerous. Reading the bromine story reminded me of some of the various fume-related stories I have from my chem classes. One of our teachers made stick-out faces right next to the molten lead bromide to smell the bromine vapor from electrolyzing it. Another teacher also likes to leave open a bottle of bromine water in the lab because that's what labs smell like to him. That's so stupid. As well as, open bottles of concentrated hydrochloric acid were left on the desks and produced some kind of fumes to the point that it was painful to breathe. Of course, we were using the concentrated hydrochloric acid without being given any kind of gloves or lab coats. This stuff is dangerous. Concentrated HCl fumes. These bottles are also so old that they have some kind of crust on the outside, which seems to be corrosive to touch in some way. Why are you touching the chemical crust on bottles? Oh my gosh. My advice is to always wear gloves in the lab. If you're touching chemical crusts on bottles with your bare hands, that's probably not good. Don't do that. Don't do that, guys. This one happened 2 years ago, and it's still kind of a running joke in our department. One of my colleagues was trying to extract hydroxyapatite from beef bones using a microwave-assisted hydrothermal method. He boiled and baked the bones to get rid of any organics and ground them up. Our hydrothermal installation uses a big Teflon container which sits on top of a magnetron with a pressure seal and mechanical stirrer, actually made of an extremely corrosion-resistant silicon carbide composite. This will be important later. He put the ground bones in the container along with some 19 molar sodium hydroxide solution. He seals the device, pressurizes the vessel with nitrogen, and sets it to process. The device has a controller that graphs the temperature, microwave power, and pressure inside the vessel in real time. And while this specific extraction was going, they were looking really strange, like the values moving all over the place. Cue to it finishing, and the hydraulic mechanism that lifts the top just refused to work. No worries, we decoupled it and tried removing it manually. Absolutely no luck. In the end, we actually had to use a crowbar on very expensive lab equipment to get it off. All the while, it was lacking a black goopy liquid everywhere, including on the magnetron. Oh no, that's awful. That's probably really expensive. I don't really know how much a magnetron is, but it's significant, because otherwise he wouldn't have said it. It turns out that 19 molar sodium hydroxide under high temperature and pressure dissolves the silicon carbide stirrer and fuses it to the Teflon vessel, which had a stirrer-shaped hole in it afterwards. Lesson learned, anything can react given the right conditions. I've included a picture of what the remains of the vessel look like. Here's a picture of what this looks like, and it's just chewed right through it. This is impressive. That's some hard work that sodium hydroxide's done. Definitely impressive. Oh my gosh, I have a terrible story about inhaling chlorine gas. So I work at an outside pool during the summer, and I'm usually tasked with putting chlorine in the pool. We have liquid chlorine that we need to put in a big barrel while wearing a gas mask, big gloves, and security glasses. We were out of liquid chlorine, so I had to put in some solid chlorine. We had some in powdered form in an old bucket, so I opened it up and got a whiff of the most chemical smell I've ever smelled. It literally smelled like acid in gas form. It burned so much I started to cough a lot and my eyes were watering. Oh no, this is such an awful story already. I could practically feel my lungs bleeding. Needless to say, I was really not well for a while after that and had to rest a little to make sure I wasn't actually going to die. But yeah, lesson learned. I will never open an old bucket of chlorine without a mask, gloves, and protective glasses. This is a good teachable moment. If you are working with anything halogenated that could produce halogens, such as TCCA, trichloroisocyanuric acid, or something like N-chlorosuccinimide, after you take the lid off, air it out a bit so that you're not breathing in concentrated chlorine near you. It could also rust stuff, and that's not too great either. But for something like a pool, the scale of chlorine is just way more, so this could be like game over if you're not careful. Don't get me started on entropy. I effing hate entropy. Entropy can GTFO. Entropy always piles up in the corners of my house, in my basement, my closet, my shed, and my garage. And my wife is a machine that produces entropy. I swear, she could dirty every dish in the house while making a grilled cheese sandwich. I'm always having to clean up the entropy at my house. I didn't write this story, but I could definitely relate. Thanks for watching, and I hope you have a great day.